carbon, carbon. And then each of the carbons is bonded to three other atoms. It's bonded to two carbons, and it's also bonded to a hydrogen. So let me draw the hydrogens here. So they're also bonded to hydrogen. So this one will have a hydrogen over here, have a hydrogen over here. That will have a hydrogen over there. That one has a hydrogen over there. Hydrogen and hydrogen right over there. So if you talk about hybridization, we have three hybridized orbitals. This is sp2
Okay, to recap lang, no? To make it clear, yung hybridization, ang ibig niya sabihin doon is connect or bonding two different elements or bonding a different element sa carbon, no? Kaya sinasabi niya ng hybridization. So, connecting a different element to the carbon atom. So, tapos sinasabi niya naman is sp2 orbital, no? sp2, hybridization. So, sp2, ito yung ibig niya sabihin, itong um, carbon atom na yung electron niya nasa sp2. So, sp2. So, kita natin dito, no? So, sp2, yung carbon. So, dito lang sa taas yun. So, sp2. Yan yung ibig sabihin ng, yung, nandun yung ano niya, yung orbitals, yung mismong electrons ng carbon. So, continue tayo ulit.
hybridization, and each of these have a leftover pi orbital that has not been hybridized. It's not directly bound to, or that does not have a sigma bond to another atom. So you have these pi orbitals, and you know these pi orbitals look like these dumbbells. So you have a pi orbital over here. You have a pi orbital over here.
So, ang ibig niya sabihin dito sa pi orbital, ibig sabihin may umiikot na isang electron lang natitira kasi yung sa alam natin, yung carbon atom can be connected 4 times. So, there are already 1, 2, 3. It's already hybridized, no? So, naka-connect na siya dito sa isang element, tapos nakakonektado rin siya sa mga carbon. So, there is only one connection left, no? So, yung sinasabi niya dito is regarding only for each of these carbon atom, there is one pi orbital na electron na umiikot. So, ang ikot nito ay from, sabihin natin, starting from the back, no? The back ng atom, for example, ito yung atom, sa back niya, iikot siya ng ganun. So, it's like an 8, no? Yung 8. So, sa harapan naman, tapos iikot ng ganun, tapos dadaan sa likod. So, yun yung ikot ng orbital na natitira na electron na umiikot dito, pi orbital. So, ibig sabihin ng pi is yung kung maintindihan natin galing sa math, no? Sa kukunin natin sa math yun. Yung pi is 3.14 is equivalent sabihin natin to pag magme-measure ka a diameter of a circle which is 1, the circumference will be equals to 3.14 and etc. Mahaba yun eh. No, to be more exact. So if you take a diameter of 1, sabihin natin 1, you will always come to a circumference of 3.14. Yan yung pi. So, biglang niya sabihin yun yung pi orbital, ibig sabihin umiikot lang. So, sa circumference, umiikot lang siya dito sa around the carbon atom.
Pi orbital over here, pi orbital over there. You have another pi orbital over there, pi orbital, and pi orbital. And you know, pi orbital, I drew them like this because if I drew them bigger than that, the diagram get messy. But in general, whenever you have double bonds, like this double bond, let's say that this carbon, let me change colors so we know what we're focused on. So let's say this sigma bond right over there. Let's say that that sigma bond right over there is this sigma bond. Actually, let me do another one just so it's easier to see. Let's say that this sigma bond right over here is this sigma bond between these two carbons. This double bond, the double bond in blue, this one, or in purple right over there, that's due to these overlapping pi orbitals. That carbon's pi orbitals and that carbon's pi orbitals overlapping. I haven't drawn them overlapping, but, well, actually, an electron can really show up. It's all probabilistic anyway, but I could draw them big enough, they would overlap, and these electrons would form that extra pi bond. What happens in a conjugated system of pi electrons, let me write that down, it's a very fancy word, conjugated, conjugated system, system of pi, let me write, make it, yeah, pi electrons, conjugated system of pi electrons. These guys, as we see, they could be bonded with each other. These guys could overlap. So there could be an overlap going on over here, or we could flip into this configuration where this guy would overlap with this guy over here. And the reality is that these pi electrons will actually be able to float around the ring. They'd actually be able to float around all of these pi orbitals right over there. They'd actually be able to float around the ring. So that's what people are really talking about when they talk about aromatic compounds or aromaticity, that because of this, this is a
So, to simplify lang yung sinabi niya, regarding dito sa pi orbital, there is only one electron na umiikot dito sa orbital nito, one electron din sa umiikot dito sa pi orbital nito, and one din dito, and one din dito, and one din dito. So, each of this carbon, meron siyang one pi orbital, no? So, equals to 6 pi orbitals lahat to. So, ang mangyayari dyan is dahil sa molecular geometry niya is a planar, no? Plane siya. Mapipilitan itong electron dito to also to have a planar, ano, sabihin natin yung plane din siya katulad nito. So, magiging plane din siya. Tsaka din ito. So, mapipilitan siya na maging plane, silang dalawa. So, ang mangyayari niyan, kung ito ihihiga ng ganon, higa rin yung ikot niya, hindi na paakit baba, akit baba, kung hindi pa side na lang, no? Pa side. So, ang mangyayari diyan is nandito na lang itong magiging orbital nitong dalawa. So, pag ganon. So, may isang electron to, may isang electron din to. So, magkakaroon ng covalent bond sa loob nito. So, yung isa papahiramin yung isa ng electron, tapos yung isa papahiramin din yung isa ng electron. So, magkakaroon dito ng covalent bond, no? Mag-share sila ng electron, then you will have a double bond dito. So, kung itong dalawa, magkakaroon sila ng double bond, itong dalawa, magkakaroon sila ng double bond, itong dalawa, magkakaroon din sila ng double bond dito. So, covalent sa loob nito ng covalent bond. So, tatlong um, double bond ang mangyayari dito sa loob ng benzene ring nito, na tinatawag na conjugated system of pi electrons.
more stable compound. And the most typical one you're going to see is the 6 carbon chain with 3 double bonds, benzene, or things derived from them. But there actually are more general ones. In general, you're going to see anything that has 4n plus 2, 4n plus 2 pi electrons in a cycle is going to have aromaticity, or it's going to be an aromatic compound. So let's just confirm this actually makes it. So each of these guys over here have one pi electron. Even though this looks like kind of two bonds, remember this is one pi orbital right over here, and you have one electron that's going to be in this entire pi orbital. So this has one pi electron, two, three, four, five, six. Another way to think about it, each of these double bonds involves two pi electrons. So one, two, three, four, five, six. So that follows what is called Huckel's rule. That follows what is called Huckel's rule. Huckel's rule, I think there's two dots above U. Huckel's rule, maybe? That follows Huckel's rule because if you set n is equal to 1, 4 times 1 is 4 plus 2 is 6. So 6 pi electrons work. If n was 2, you'd have 4 times 2 plus 2, which is 10. So if you had 10 pi electrons, it would all.
So, yung Huckel's rule nito regarding to sa sa 4n plus 2. So itong n nito is a variable, so it could be any kind of number, no? So regarding kay Huckel's is ano ba yung gagawin niyang aromatic compound, ano yung hindi? So nag-research sila na kung yung planar ba, lahat ng planar pwede bang maging aromatic compound. So sa theory nila ay itong n nito is equals to 1. So 4 times 1 plus 2 is equals to 6 carbons enabled to have the 3 double bond na sa loob ng benzene ring nito, kaya itong hexagonal shape with 6 carbons na nandito sa every bend yan, no? So ang rule niyan is every bend is a carbon atom, yan sa organic chemistry. So itong 4, yung Huckel's rule is 4n plus 2. Ibig niya sabihin dito ay itong carbons. Yung carbon yan. So 4 times 1 plus 2 is equals to 6 carbons.
Also work. So a molecule that looks like this, let me see if I can draw it. A molecule that looks like this would also work. So if you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 carbons, and then you had 5 double bonds. So 1, 2, 3, 4, 5, just like that. You can imagine these guys could flip around, but this would also be an aromatic compound. This has 10 pi electrons. Each of the carbons have a pi electron, or you could count the pi electrons on each end of these pi bonds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
So to be specifying aromatic compound, no? So makikita natin dito bang
hexagonal siya. So, 1, 2, 3, 4, 5, 6. 6 carbons. Meron siyang 3 double bonds sa loob. So, ibig sabihin yun yung 4n plus 2, no? 4 times 1 plus 2 is equals to 6 carbons. Yan palagi yung rule ni Huckel's rule na sinasabi niya na yung following that rule is the will have the aromaticity, no? So continue.
Now, this is one thing that I always wonder. It's like, okay, it worked with 6, it worked with 10, but what about 8? It seems like with 8, maybe these electrons, these double bonds could flip around just as easily. So what if I had, or even 4, what if I had a molecule that looked like this? What if I had a molecule that looked like this? Or a molecule that looked like a stop sign? So 1, 2, 3, 4, 5, 6, 7, 8, that had double bonds that alternated like this. You might say, hey, maybe those also are aromatic compounds. Those also experience aromaticity, because couldn't this guy jump around here and then that guy over there and the electrons cycle around, or this guy jump over, these electrons move there, those move there, those move there, and those move there. And it turns out that in these compounds, it's actually, the electrons do not, the pi electrons do not stabilize the system. But this is actually less stable than if it was not in a cycle. So actually, this is these right here that don't follow the 4n plus 2. So 4n plus 2, you're talking about 6, 10, 14 pi electrons, which usually means 14 carbons or 10 carbons or 6 carbons. The ones that don't follow them but are still cyclical and still have these alternating bonds, these are called anti-aromatic. These are anti-aromatic, and are actually very unstable. These are very, very unstable and are more likely to break into a non-cycle. Anyway, hopefully you found that vaguely useful. We touched on this in the video on.
So balikan ko lang, no, recap lang to. So pag may lumabas na tulad ng in-explain niya dito. One moment. So, itong shape nito, no? In-explain ko na sa first video na itong mga conjugated pi electrons na nagsa-circulate dito ay active siya, no? So, gumagalaw yan. So, pag gumagalaw ito, imagine niyo lang na parang gulong siya nasa loob na umiikot. So, with a certain speed, ganito magiging ano niyan, ganito yung magiging forma niya sa loob. So, this stabilizes kasi inaano niya, dinidistribute niya yung charge niya dito. Bawat isa niyan. So, it could be illustrated ganito or ganito, no? So, hopefully nakatulong tong video sa inyo. And I will also forgot to say na meron ditong dynamic periodic table. It's very useful para sa inyo, no? So, just type dynamic periodic table. Andito na lahat, pati na yung mga orbitals, andito na rin. So, makikita nyo dito sa kung ano yung shape ng orbit niya, kung paano siya nag-orbit yung electron, no? So, dito circular siya. Sa helium naman, so, ganun din. So, yun yung covering niya. So, bibilog na ulit. So, ito naman pa, 8. Okay.